Hello everyone. Welcome to our another video in the series on mastering data structures and algorithms. Today we'll be beginning with a new topic on circular linked lists. So let's begin. I'm Dr. Prashanki Gupta. There's a link to my website that contains lots of good materials. Please have a look on it. So let us begin with what is a circular linked list. Circular linked list is in a number of ways quite similar to the one way or the singly linked list that we have already done. The difference comes in the fact, in case of a singly linked list, the last node contains the address as null. However, in case of a circular linked list, the last node points to the first node in the linked list. So idea is that over here, as you can see, the last node over here contains the address of the first node, and rest all other nodes are same. That is, you have a start node, then there is a first node with the information link part, and all other nodes follow the same suit. So the last node is identified with a link equals to start instead of null, as in case of single linked list. How to create a circular linked list? Creation involves declaring the start pointer, as in case of the single linked list, as well as other nodes with the two fields like information part and the link part. Link field of a node also contains the address of the node next to it in the linked list, except the last node, which contains the address of the first node. Therefore, the structure declaration is exactly the same as in case of one-way linked list, or you can say in case of a single linked list. It contains the name struct node, that is the name of the node, information part which is declared of the type int, and a link part that contains the address of the next node into the linked list, and it is of the type struct node. Therefore, as in case of one-way linked list or single linked list, start pointer and other nodes are declared as data types of this structure, that is of the type of struct node, and any two nodes need not occupy the adjacent memory locations. New node that we create or add every time into the linked list is allocated memory dynamically using the previous scenario, that is using the malloc functions. So here it is time for some programming. We are creating a circular linked list and adding a node to it. Maybe you can say it is the first node. So as you can see, these are the header file declarations, and this is the node declaration. Then comes our main function. Inside the main function, we declared the node variables, start node and the new node. Then we are prompting the user to provide the data. We are declaring the data type as of type int, and over here we are prompting the user to provide the value of the data to insert into the first node. Then we are allocating the memory to the new pointer dynamically using the malloc function. The data entered by the user using the scanf function is input or added to the first node using this assignment statement, that is news info equals to data. Now over here you can see a marked difference in case of the circular linked list as compared to the one-way linked list. In case of one-way linked list, we had declared news link equal to null. In case you don't remember, please go back and watch that video. So over here you can see now new link is equals to start, because it is the only node that is added into the linked list. So it is the first as well as the last node. So being the last node, its null value points to the start variable. And then we are allocating the address of the new to the start, which is same as in case of one-way linked list. So thank you all for watching this video, and don't forget to subscribe to our channel. More and more good videos will be coming up soon. Thank you.